I'm sure you've seen charts and graphs like these. They are often used to communicate statistical information, to influence opinion, or to help you make decisions. For example, here's a chart which shows fuel consumption over the past 50 years. By looking at this chart, can you tell if conservation efforts are having any effect? A state fish and game department conducted studies on the fish population in various rivers, lakes, and streams. By sampling the waters, among other things, they recorded the number of males and females found. Overall, there were an equal number of each, so when the results were charted on a frequency diagram, the chart will look something like this. 2 bars, one for males and the other for females, both about the same height. An experiment conducted by the environmental awareness organization Students for a Better Earth involved carpooling. The number of people per car was recorded. As you can see in this table, most of the time there was only one person in each car. When we put these results on a frequency diagram, we get a strange-looking graph. The bar for one passenger per car is much higher than the rest. The graph slopes down from left to right.
Off tower runway 14 left in use, wind 150 at 10, altimeter 298.44 miles.
The Air Force Training Command conducted a study to determine the average number of maintenance items performed each month on their fleet of trainer aircraft. When they took the survey results and plotted them, they ended up with a frequency diagram that looks something like this. The graph starts out low, gets taller in the middle, and then goes back down. Another experiment involved a medical facility that was trying to judge the effectiveness of its physical therapy program on patients who were disabled. The level of activity for one woman who did not seem to be making any progress was recorded on a diagram that looked something like this. Out of 6 different visits with the physical therapist, all 6 sessions produced equal results. Finally, another medically related study was conducted by a college athletics department to determine the endurance level of various student athletes. A variety of students were tested and the results plotted on a frequency diagram of endurance levels. Going from left to right, the graph starts small, builds to its highest point in the middle, and then goes back down. Each of these experiments provides you with some common patterns that we can identify and interpret. For example, this pattern, like we saw with the fish population and physical therapy study, is called a rectangular pattern. It occurs when each of the items you are plotting have an equal probability of occurring. This next pattern is by far the most common type of frequency distribution you will encounter in statistical applications. It's called a bell-shaped or normal curve. The reason it's called a normal curve is because it's the type of distribution that's normally expected in most statistical investigations. There are mathematical reasons for this, but a simpler explanation is to look at the world around you. There is a great amount of diversity. This is something statisticians call natural variation. You might compare 2 objects that appear to be identical and determine that they are exactly alike. There is no variation between them. However, if you examined them very closely, you would find subtle differences.